Okay, classes are kind of at different paces right now, but right this lesson I'm teaching my class is about domain and about using the vertical line test to tell if something is a function or not. All right, so if we're talking about the domain, I want to go back to a simple one. This is a parabola, right? Y equals x squared. Do you remember that? The domain of it is about the x's of it. There's domain and there's range. The domain is about the x's. I'm going to put a little x here. The range is about the y's. And if I'm going to do the domain of this, I want to know about the x's. The question is, what x's would work? Can I go forever this way as this thing, extends out? Can I go forever that way? Yes, I can. So it would be from negative infinity to how far can I go this way on my x's? It'll go forever, positive infinity. And I put a parenthesis around them because I'll never actually get to infinity. Do you remember doing that? All right. How about the range? The range is about up and down. Where the domain is about left and right, the range is about up and down. Okay? On your range, what's the lowest that this thing goes? 0. To what's the highest it goes to? Infinity. And so, again, does it get to infinity? No, but does it get to 0? So, therefore, it's a bracket around the 0. All right. Do you remember domain and range? Okay, good. So now, when we do domain and pre-calc, it's a little more difficult, of course. It's not just the easy ones that are pictures. What if you don't have a picture? What if it's like this? And we're trying to figure out the domain of this. Well, the domain is without a picture. The domain is the numbers you can put in for x. Remember, these are the x's. Well, I can pretty much put anything in I want, unless it messes up one of two things, and these are the things you need to watch out for. Okay, so underneath domain, I'd like you to write domain dangers. The domain dangers are square roots that are negative. That's a problem. You don't want that to happen, to have negatives under the square roots. And the other thing is denominators that are negative. Those are the two things you watch out for on domain. You don't want denominators, I said negative, I meant 0. I'm sorry. Denominators that are 0. Sorry. You can have negatives in the denominator, you just can't have 0. And square roots that are negative. Those are the two things to watch out for. Okay, so in this problem here, I don't even have any square roots, so I have nothing to worry about there. Do I have a denominator? Yes. I got to watch out and make sure the denominator is not 0. Okay? So I want to figure out where is the denominator going to be 0. Now this one is pretty obvious. It's going to be when x is negative 2. Get what I'm saying? If I put a negative 2 here, the denominator is 0. I don't even care what's on top, because if there's any 0 on the bottom, the top doesn't even matter. The whole thing doesn't work. Okay? It is called undefined if there's a 0 on the bottom. Just to back it up a step, do you remember this? One of these two is okay, and the other one is completely impossible. I've just told you, so I hope you can tell now. This is the one that's impossible. It's an error. It's undefined. This one is totally okay. You can take 0 and divide it by 5, and you get what? 0. If you had 0 cookies and you divide it amongst 5 people, you still have 0. It's easy. You can't take 5 cookies and divide them into nothing. Only unless you're a magician. Okay. I can make cookies disappear. That's completely different. All right. So on this one, if I put in a negative 2, I will have a problem. So how do I write my domain? My domain is all real numbers except for negative 2. So the way you write that is, I can go from negative infinity all the way to what before I have a problem? Negative 2. I can go from negative infinity, and I can't ever get there, to negative 2, and I can't use that. You get what I'm saying? And then start over again. Think of this as a big number line where -2 is the only thing that gets messed up. And then I start over again at -2, union with -2, to how far can I go? Positive infinity. So there is a domain, and what we did was called finding a domain algebraically, as opposed to graphing it and looking at the picture. All right, let's do another one like that. What if you had square root of x minus 3? That's my function. My denominator in this case is a 1. Do I have to worry about that? Nope, it's a 1. It's not going to change. So the denominator is not going to be my problem. It's the square root. What would be a problem if the square root part became what? Negative. So we want to set the square root part to be positive. So for my domain, I want everything that's going to be where this is positive. Then I'll be okay. So how do I write that? I say x minus 3 needs to be greater than or equal to 0. Isn't it okay if it is 0? Square root of 0, is that a problem? No, square root of 0 is 0. It's okay to have a 0. That's why it says or equal to. So what did I do? I take what's underneath here and I set it greater than or equal to 0, and that'll tell me my domain. Now I just add 3 to both sides. That. And I get x is greater than or equal to 3. Okay? There's my domain. Now how can I write that? Does it go from -infinity to 3? Does that work in there? No, it doesn't start working until what? 3. And it keeps working until infinity. So there's my domain. Does it work at 3? So I put a bracket. There's my domain for that one. Again, what it really comes down to is what numbers would work. And numbers that where I start at 3, 3 is okay because it gives me 0 and square root of 0 is a number. Or things that are bigger than 3 are going to work. All right, well, let's do another one. This one's going to be trickier because it's got both things to watch out for. Isn't it amazing how loud those crinkly things are when you open them in a quiet classroom? X minus 5 over x. I want you to figure out everything will work except some certain kinds of numbers. Figure out what your domain is. The domain is the things that would work, not the things that won't work. Your answer should be something like this. One of those kind of deals. Might even be a union of 2 different places. But the best way to think of this is as a number line. Would you agree I'd have a problem if x was 0? That's the thing to watch out for in the denominator. So I better make sure that x is not 0. So I'm going to put a 0. I'm going to put an empty spot on 0. Okay? Would you agree that there's something important about the number 5? Because if I put a 5 here, it's right on the edge of making this thing negative. But is it okay to be 5? Yes. So I put a 5 on here. It's an important spot. I'm going to put it filled in because it will work at 5. And now, do I want things that are bigger than 5 or less than 5? Bigger. The things that are going to work are things that are bigger than 5. Now, my question to you is, how do I figure out if things work in here or there? Test them. Like if you wanted to make sure that you were right on your domain, I think the domain is going to be 5 and bigger. Let's say I think that that's what it is. 5 to infinity. Works at 5, doesn't work in infinity. Let's say I think that's right. What should I check? Maybe I should check like a number like 2. You know what I mean? Like check something in here. See if I didn't make a mistake. If I put in a 2, is it going to work? No, because I'll have a negative under the root. Okay, so it definitely doesn't work in here. And how about like things like -10 or something? I'd have negative 10 minus 5 would be negative 15, and then I got the square root of a negative, and that's not good. Throws it out. So, yep, it's 5 to infinity. Okay? So you're trying to make a list of the things that are going to work. All right, the things to watch out for are square roots or denominators that become 0, square roots that are negative. All right, so let's do one more. Let's say I had 5 over x squared plus x. I'm not even worried about square roots on this one. It doesn't even have one. But it does have a denominator. And I'm not supposed to let the denominator be 0, right? So what am I going to look for? I'm going to try to find the places where this equals 0. And I'm going to try to avoid those spots. I want x squared plus x equals 0. Do you know how to solve that? You should. It's a quadratic. I've taught you 3 ways to solve them. Quadratic formula, graphing them, factoring them. What's the easy way? Factor. Can you factor that? You better be able to. All right. And then what are my 2 answers? X equals what for this? 0. And what for this? So if x is 0, am I going to have a problem? Yep. So if I'm making my little number line, everything works except 0 is going to be a problem. Can't be 0. And how about negative 1? Can that work? Nope. Negative 1 is going to be a problem. Now, how about all the other numbers? Could I test numbers? Sure I could. Do I even have to? Nope. Because everything works except these 2 numbers. I know if you test a number in here, it's going to be fine. And if you test a number in here, it's going to be fine. And that's going to be fine. So it's like this. So how do I write that? It's a triple union. It's from negative infinity to negative 1, union with negative 1 to 0, union with 0 to infinity. All right, I'm going to give you one more that's a lot like that. Try this one. What's the domain of that function? Make yourself a number line. It'll really help. Well, I want to know where 2x and x plus 1 will equal 0. And that'll be at x equals 0 and x equals negative 1. And oh my gosh, it's the exact same thing as we just did. Negative 1, 0. And except this time, I'm not going to need to test all of these spots. I know they're all going to work. Everything works here and here and here. So I hope you said negative infinity to negative 1, union with negative 1 to 0, union with 0 to infinity. Raise your hand if you get that. Okay, good. So you're understanding domains. How about the vertical line test? It's easy as pie. If I have a graph, that graph will be a function as long as you can take a vertical line. I'm going to take a bright blue one. And my vertical line better never touch it twice. Because if it did, what that would mean was, like for instance now, that's not a function. Because now my vertical line touches it twice. That means that this input of, let's say that this is like at 6 here. 1, 2, 3, 4, 5, 6. That's at 6. My input of 6 is giving me 2 outputs. Let's say that that's at like 4 and that's at like 10 or something. It's got 2 different outputs. Not supposed to touch twice. One input's only supposed to have 1 output. Okay? Do you remember the vertical line test? And this is going to be an easy one because they're going to give you a picture. And you're going to say function or not a function. I want you to tell me right now, function or not a function? Function, because it passes the vertical line test. All right, how about this one? Function or not a function? Function. Because it passes the vertical line test. Oopie, I got rid of my axis too. Here's one they like to do a lot. Function or not a function? It's a function. Because at this one spot where you're probably thinking, right there, doesn't it touch in two spots? No. No. See that empty hole? You know what that means? That means specifically that it does not touch there. That's what an empty spot means, is that it doesn't touch there. It touches at the dot, but not at that empty hole. So that means there is only one output at this input. If the input of, let's say that this is at 3, that input is not touching right there. It is touching right there. So this one is a function. All right. How about, it's a classic, circle. Function or not? No, circles are not a function. Because my vertical line test, it would touch twice in a lot of places. Are there some spots where it only touch once? Yep. Like right on the edge. You know what it's called when a line just barely touches the circle only once? It's called the tangent line. I'm going to learn more about that later. All right. So half your assignment is just domain. Oh, 3/4 your assignment is domain, and the other 1/4 is this a function or not? So it's really easy stuff today. We'll get into the harder stuff. There is hard stuff related to this later. So now what do we do? Well, I'm going to stop the video for one thing. Oh, wait. Assignment. Put it up there in case you're watching the video. That goes along with this was that one, page 1021 to 16. Some of the classes are going to do 17 and 18, but those are about range. And when I tried to teach that today, I had lots of people that looked all crazy-eyed at me, so I decided to just throw it out, and we won't worry about that until you come back from the plan test on Thursday. We'll teach range then. Okay, so this is 1 through 16 only. And that's it for the video.